So in this video, we're going to be talking about how to solve one-step equations, and this hopefully is a review for most of you. Step one is going to be to remember that an equation just means that both sides are equal. You can kind of think of it as a balanced scale, and so we want to make sure that we see the two sides of the equation. So our first step is going to be to cut it in half, and you're going to do that through the equal sign. All right, after you cut it in half, you want to isolate the variable, and that just means to get the variable by itself. If you're in isolation, you're all by yourself. Step three is that you're going to use the opposite operation to solve the problem, and we call this the inverse operation. So for example, the opposite of adding would be subtracting, and the opposite of subtracting would be adding. Okay, the opposite of multiplying is dividing, and the opposite of dividing is multiplying. So those are inverse operations. Okay, and then at the very end, you need to just finish by solving and checking your answer. Okay, so important thing to remember is because an equation, each side is equal to each other, then you want to keep it balanced, keep it equal by doing whatever you do to one side, you have to do the other side. All right, so here's an example of an equation. Equations have equal signs. X plus 2 equals 5. Our first step is to cut this in half. And so we can see that on one side we have x plus 2, and on the other side we have 5. Now, from time to time, you're going to see models of equations. So I'm just going to show you a couple examples of these. But if this were a balanced scale, we could think on one side we have the x plus 2, and on the other side we have the 5. To model a variable, usually they sometimes use algebra tiles. They're usually the long piece, and they're marked as x. And then you have plus 2. It's like having two positive integer chips on one side, and then you have that side is equal to 5 on the other side, so that's like having 5 positives on this side. All right, and so if we wanted to solve this so that we just knew what x was, what we would have to do is get rid of two of these two positive chips right here. So if I take away these two chips here, then I need to also take away two chips here. So if I take away these two, then I have to take away 2 on this side, and then what am I left with? I'm left with 3. Okay, so that's modeling the equation. When we use the steps to do this, we're going to cut it in half so we can kind of see the picture of what's going on here. We want to isolate the variable, so I'm going to identify the variable. That's the letter x. It's being added to 2, so to get rid of the adding 2, we have to do the opposite operation. The opposite of adding 2 is subtracting 2, or adding a negative 2 would also cancel out a positive 2. So if I subtract 2 here and I subtract 2 on the other side to keep it balanced, okay, then adding 2 and subtracting 2, those are inverse operations. They go away. So all that's left on this side is the x, okay, and then 5 minus 2 on this side would be 3, okay? So essentially, what we did here is the same thing as what we did here. We just didn't draw a picture of it. Now you can always check your answers in an equation by plugging in your solution to the variable. All right, so if I go ahead and replace x with 3, then that would be 3 plus 2. And then is that equal to 5? So this is where I replaced x with 3. So yeah, so 3 plus 2 is 5, so this is the correct answer. All right, and on this next one, we're still adding, so I'm going to go ahead and cut this in half. I'm identifying that this is my variable. It's being added to 4.2, so I'm going to do the opposite, which is subtracting 4.2. I'm going to do that on this side as well. So adding a positive 4.2 and adding a negative 4.2, those will go away. So on this side, I will just have x. And on this side, since I have a negative and a negative, subtracting 4.2 is the same thing as adding a negative 4.2. So really what happens is I end up, since these are both negative, I just add these together. So 0.3 and 0.2 gives me 0.5, 7 and 4 gives me 11, and 2 negatives stay negative. So this is negative 11.5. And again, I can plug this back in to check my answer. I'm not going to do that every time just because I don't want this video to take super long, but you can always check your answer by plugging it back in. All right, let's look at 3 over here. I'm going to start by cutting it in half. This time my variable is on the right side, which it doesn't matter because, again, it's just saying this side is equal to this side, so it really doesn't matter. The variable is right now being subtracted by 3, so in order to get rid of subtraction, I'm going to do the opposite, which is adding, right? The inverse of subtraction is adding. So I'm going to add 3 to this side. If I add it here, I have to add it on the other side as well, on both sides of the line. Okay, subtracting 3 and adding 3, those go away. So this side is just x, and then 4 plus 3 is 7. Again, if you want to check your answer, you plug it back in here. So 4 equals x is now 7. Is 7 minus 3 equal to 4? Yes. And then this is the correct answer. All right, if I want to see what that looks like in the model, all right, then on this side I have a positive 4, so I have 4 positives. X, I'm just going to use a box to indicate x, and minus 3, in order to identify that, instead of subtracting 3, there's no way to show that. What I'm going to do instead is think of this as plus a negative 3. I'm going to have 3 negatives over here. All right, so for this problem, I need to get rid of the 3 negatives, but there's no negatives on this side, so I can't just cross out 3 negatives on this side. So what I have to do is think about what cancels out a negative. Okay, well, I know that 0 pairs cancel each other out. So a negative plus a positive, a negative 1 plus a positive 1. If I have $1 and I spend $1, then that's equal to 0. So anytime I have a negative and a positive, they cancel each other out. So if I want to get rid of 3 negatives, then what I need is 3 positives. Okay, so I got a negative and a positive, those will go away. A negative and a positive, those will go away. And a negative and a positive, those will go away. Okay, but what I did was I added 3 positives over here. So if I do it over here, then if this is going to stay balanced, I have to do it over here as well. So I'm going to add 3 positives over here. And so now I can see that there's nothing on this side but x. And over here I have 1, 2, 3, 4, 5, 6, 7, which is what I got as my answer over here. Okay? All right, if I continue looking at the next one, I'm going to cut it in half through the equal sign. I've got the variable y. I want to get that by itself by getting rid of minus 1/10. So I'm going to add 1/10. I'm going to add 1/10 on this side. These go away. This side is just y. Now, because these are fractions, in order to add them, I have to have a common denominator. So the multiples of 5 are 5 and then 10. So I can change this to 10 if I multiply 5 by 2. So I need to multiply the top by 2. That gives me 4/10. This stays 1/10. So I'm going to do 4/10 plus 1/10, which gives me 5/10. This can still be simplified. These are both divisible by 5. So that becomes 1/2. So y is equal to 1/2. Okay? All right, I also want to look at when I have multiplication and division in an equation, how I solve with those. So 2x, remember, anytime you have a number next to a variable, that's another way to write multiplication. So this means 2 times x. So 2 times x is equal to -6. I'm going to do this the same way, cut it in half. Since this means multiply, the inverse operation would be to divide. So remember, I can write divide as a fraction, so that's how I'm going to do it over here. I'm going to divide by 2. So multiplying by 2 and dividing by 2, or 2 over 2, that's like 1 whole, just makes this go away. So this is just x now. And -6 divided by 2 is 3, and it's going to be negative because of this guy right here, right? A negative positive is negative. So x equals -3. And I can check that answer by plugging it back in. Is 2 times -3 equal to -6? Yes. Okay? If I want to look at this on my scale, balance scale, then when I have 2 x's like this, this would be like 2 large algebra tiles, 2 x's. And over here I have 6 negatives, so I could do it this way. Okay, I have 2 x's and I have 6 negatives, and I just want to know what one of these x's is. All right, so since there's 2 here, I have to divide my negatives into 2 groups. So if I divide these evenly into 2 groups, then I can see that 1x is equal to one of these groups. So then 1x is equal to 3 negatives, which is what I got here. X equals -3. All right, so again, just another way to model multiplication. It's kind of hard to model division, so I'm not going to show you that, but it does work the same way. You're going to cut it in half. This is another way to write division. I need to get the x by itself. Right now it's being divided by -2. So the opposite of dividing by -2 is multiplying by -2. I'm going to do that on both sides of my equation. So dividing and multiplying, those go away. This is just x on this side. And -2 times -7, and negative times a negative is positive, so this would be positive 14. So I'm really multiplying this. Okay, again, I can check my answer if I want to. Is -7 equal to 14 divided by -2? And yes, that's 7, it'd be negative, so this is correct. Okay, all right, sometimes you have fractions mixed in. 1/3 y equals 9. this is multiplication. This is still a number next to a letter. So the opposite operation after I cut it in half is to divide. So I need to divide by 1/3. So over here, I'm dividing by 1/3. So multiplying, dividing, these just go away. So on this side I have y. Bring down my equal sign. And then here I have 9 divided by 1/3. So I'm going to change my 9 when I'm dividing by fractions into a fraction by making it 9/1. And then I'm going to keep, change, flip. So I'm going to keep the 9/1, change to multiply, flip this to 3/1, and then multiply top times the top and bottom times the bottom. So 9 times 3 is 27. 1 times 1 is 1. And then this simplifies to just 27. So y is equal to 27. And I can check that. Is 1/3 times 27 equal to 9? Well, if I make this 27/1, I'm going to get 27/3, and 27 divided by 3 is 9, so that is correct. All right, and if I look at the next problem, I have 6 equals x over 5.3. So again, I'm cutting it in half. This is the variable I'm trying to get by itself. It's being divided by 5.3, so the opposite of dividing is multiplying. I'm going to multiply both sides by 5.3. Right, so these go away. This side is just x, and then 5.3 times 6 is 18. Carry your 1. 6 times 5 is 30, plus 1 is 31. There's 1 decimal here, so 1 decimal here. My answer would be 31.8. And again, you can check this if you want to divide 5.3 into 31.8, top in, bottom out. That's what this would be. Okay, move your decimal over. Move your decimal over. Is 53 into 318. Is that going to be 6? 6 times 3 is 18. Yeah, then that's what I'm going to get. Okay, so my answer is 6. So this is the correct answer. All right, so that is one-step equations. Again, remember you're cutting your equation in half, and then you're isolating the variable, and then you're using an inverse operation in order to solve it. Again, you can always check your answer, so hopefully you'll never miss one. All right, see you soon.